Hi, grade 10s. So today we're going to talk about transport across membranes and the different ways that this can actually occur. So when I'm talking about membranes, we're going to focus mostly on membranes that happen that are present in cells. Okay? So cell membranes only will allow certain substances to cross the membrane. Some things can, some materials cannot. But how does this occur? How do chemicals actually move in and out of the cell? So we are going to talk today, specifically about passive transport. And what passive transport is passive transport is a type of transport across a membrane that does not require any energy exertion from the cell. The motion just actually occurs. The substances just enter and leave because of the energy of the actual particles. Okay, so how does this actually start? Okay, how does this kind of happen? So it all starts with something called Brownian motion. Okay, so what Brownian motion is, it is the random movement of particles that are suspended in a liquid or a gas. Okay, so what does this actually mean? So if you were to look at this little animation over here, okay, imagine the yellow dot, okay, is a salt particle in water. You can't see those water particles that the salt is actually in. And the water particles are actually moving at random. And because the water particles are moving at random, it actually also means, okay, that it's causing random motion of the salt. You can see actually there that it starts off, start again. You could actually never predict which way it's going to go. It could maybe go down, but it could go up, it could go right, it could go left. And so because of one of the particles' random motion, it causes the other particle's random motion. And the reason it causes it is because basically, if you look, those water particles are actually striking the salt particle. So it's causing the random motion of it. And this happens in a gas, okay, or a liquid that particles are suspended in. So Brownian motion actually leads to diffusion. This is a concept that you learned in grade 8. Okay, and diffusion is the movement of particles from areas of high concentration to low concentration. Okay, and you'll often see it kind of shorthanded like that. So if you were to look at this animation when it starts, I'm going to let this start again. You can't see the gas or the liquid that it's in. There are just red particles that are in something. So they start extremely highly concentrated, and we would say that they diffuse from their high concentration to a low concentration. And that is because of the random motion. As one starts to move, he'll hit another one, and you never know which way it's going to go, but they will always go from high to low. We see this in your everyday life. Okay, if you think about popping a bag of microwave popcorn, usually it's in high concentration right when you first take it out of the microwave, but that smell, those smell particles will actually transport from high concentration to a low concentration until it's basically evenly distributed across the room. Okay. And that is something that we can almost always predict, even though we can't actually predict the random motion. So the random motion, interesting enough, allows us to know that it's going to go from high concentration to low concentration. Okay, so when there are areas of high concentration and low concentration of particles, we say that there is actually a concentration gradient. Now, this might be a new term to you this year. Okay. And in diffusion, when the particles move from high to concentration to low concentration, we would say they move down the concentration gradient. Okay. So basically, there is a concentration gradient when you have an area of high concentration, low concentration. So this area, if you look at this diagram, is high concentration, low concentration. So we should be able to predict and know that because of Brownian motion and the random motion that the particles have, the particles are going to overall, in general, move in this direction. Now, saying that, that doesn't mean that there might be some odd particle that's moving this way a little bit. Okay, we don't know, it's random, but overall, it's going to go from high concentration to low concentration. Okay, where in this diagram, there is no concentration gradient because there is equal concentration throughout. Okay, this is what we say is in dynamic equilibrium. So what dynamic equilibrium means, dynamic equilibrium, dynamic meaning still constantly in motion. These particles are still moving. It might be moving this way, it might be moving this way, this guy might be moving this way, up, down, okay? But overall, because the concentration is equal, equilibrium, concentration is equal throughout. Okay? So, we are going to talk about some words to help us be able to compare concentration. So these three words are the following: isotonic, hypertonic, and hypotonic. So if a cell has equal concentration on, let's say, inside and outside of it, it would be what we call isotonic because it has equal concentrations on both sides. But hypertonic, if you have one side that is more concentrated, it would be hypertonic. And hypotonic would be the less concentrated side. So what does that exactly kind of mean? So if I was to look at this area right here, write a pen, let's say this is area A. Okay, if I was to compare area A with, let's say, area B, these two areas, okay, the circle area that I've kind of went with, those areas seem to be like they're fairly equal in concentration. So I could say that A and B are isotonic. Where if I was to draw or look at another area of this, so let's say this is area C right here. If I was to compare area A and area C, I would say that A compared to C is hypertonic. Okay, it is more concentrated. So A is hypertonic compared to C, where C is less concentrated, so C is hypotonic compared to A. And so when we use these words, hyper and hypo, we always have to do it in a comparison. You can't just say something is hypertonic because hypertonic to what? So it is a comparison. So we are going to use these to help us identify which way substances are going to flow. So predicting movement. This is something that you're going to have to be able to do at the end of this lesson. So let's say this whole thing is a cell. This is the inside, this is the outside, here is your membrane. Your membrane is what's going to allow things to enter or leave. So if you were to start with this, okay, I would maybe identify, because I'm going to compare these two, I'm going to say that the inside of the cell is hypertonic because from what I can tell, let's say the red guy is salt and the blue guy is sugar. It looks like, okay, the inside of the cell has a higher concentration of sugar and salt, where the outside of the cell looks like it has a lower concentration, so it would be hypotonic. So this would be your lower concentration of solute. And I just said the word solute, so it's another grade 8 term. So that's basically whatever is dissolved in it. And it's the substance dissolved, and this is higher concentration. All right, so these are usually dissolved in water. You can't actually see the water at the moment, but we're going to talk about water and transport pretty quick here. So if I was to make a prediction, I would say, okay, well, this one has higher concentration, this has lower concentration, so therefore my particles should be moving with no energy requirement from the cell from a high concentration to a low concentration through the process called diffusion. All right, so there is another type of diffusion, okay? But this is actually what we call facilitated diffusion. So it's diffusion because it's still from a high concentration to a low concentration. But the thing is, not everything can easily just move through the membrane. Some substances need some assistance, and they need assistance through something called a transport protein. So if you think about a transport protein, you can kind of see in this image right here, it looks almost like a little channel. Okay, so sometimes they could be channels, but basically their job is to help. Okay, and it could possibly change the shape of it. It could make a channel. It allows the substance to go through the membrane. Still no energy requirement, and still from high concentration to low concentration, aka down the concentration gradient. Okay, so now osmosis. Osmosis is one you're also familiar with. Okay? It is the diffusion of specifically water. So it is water particles only moving from high concentration to low concentration. If you were to look at this animation, okay, the blue and the white guys here, these are your water particles. So right at the beginning, just wait for this to reset, right there, you would say that there is a higher concentration of water and a lower concentration of water on this side. And from what you can see, the membrane is actually allowing the water to go through it. So the water is moving overall in general from a high concentration to a low concentration. But you will also notice that there's these green particles here. Now these green particles aren't dealing with the water at all. These are actually a different substance. So let's say, for example, the green guys, should make this more green, is salt. You will notice the greens aren't actually moving. That means with this specific membrane, it's not allowing the salt to go through it. Okay, but I would still be able to identify which side has a high concentration of salt and which one has a low concentration of salt. In this case, the left side actually has a low concentration of salt. So because of that, this side would actually be hypotonic, because that hypotonic and the hypertonic is actually talking about, like I said, the solute, not the water, but the solute. So on the other side, we have a high concentration, so this would be hypertonic. So if the salt could move, it would actually move from the right side to the left side if the membrane allowed it. So it is not strictly a memorization of things moving from hyper to hypo, because it actually depends on what is doing the movement. So overall, this is what we have covered in this little lesson. So passive transport, the big thing here, is it requires no energy from the cell. Okay? And that is because of starts with Brownian motion, the movement of the particles. That Brownian motion is the random motion of the particles. That random motion affects our concentration gradient. Okay, so concentration gradient means that you have different areas of concentration, so high to low. And in general, with passive transport, overall, there it's going to move down the concentration gradient from high to low. So our three types of passive transport are the following. Diffusion. Okay? This is just through the membrane, and it's going to go from high to low. And this is where we started talking about hypertonic concentration and hypo. So hyper means there is more solute dissolved, and hypo means less dissolved. Facilitated diffusion means that it needs a little help from a transport protein. Okay? So it's just helping it along, still no energy. Where water is involved with our third type of passive transport, which is osmosis. And osmosis is specifically in water, and it is specifically a requirement that it needs a cell membrane for this to occur. And it is still going to go from high concentration of water to low concentration of water. So these three diagrams right here would be a great thing to put down in your notes just for visualization to compare them. You're obviously not going to be able to do the little movement of those particles, but you can draw the arrows to see which way they're going. So yeah, I threw a lot out there, but I am hoping at the end of this lesson you should be able to predict which way the particles are moving, and you do so by first identifying what areas have a high concentration and low concentration, identifying hyper and hypo, and then identifying whether it is through diffusion. So this could be basically any substance except water, for the most part, that occurs in. It could be facilitated, but that means that you need that little transport protein that's helping it out. And this could be any particle depending on the membrane and what's allowing it to go through. Or if you're dealing with just water transport, the process is through osmosis. So I'm going to give you guys a couple questions to try this out on. I hope you have a good rest of your day.